In this video, we're going to look at how to complete the square in order to solve a quadratic equation. So completing the square is a little bit more involved than factoring, and you might say, well, why would I ever complete the square if I can just factor and solve? Well, the thing is, there are some equations that are not factorable, so you can't factor and solve them. In this case, you'd probably want to turn to completing the square as one of your options. Alright, but before we even complete the square, I do want to show you how easy it is to solve an equation if it's already a perfect square. So let's say we were asked to solve, for example, the equation 2x minus 3 squared equals 7. So this is already a perfect square. As you can see here, we have an expression and it's squared perfectly. Alright, cool. So what do we do? Alright, at this point, you would want to square root both sides. So we would get, when we square root both sides, this is actually going to be positive and negative square root. And we have 2x minus 3 is equal to the positive or negative square root of 7. Alright, what now? We're trying to get x alone, so we would add 3 to both sides. So we get 2x is equal to 3 plus or minus the square root of 7. And finally, again, since we're trying to get the x alone, we would divide everything out by 2. And we would get x is equal to 3 plus or minus square root of 7 all over 2. So that was a relatively simple process because it was already a perfect square. Now our goal is to be able to get any quadratic to be a perfect square, and then we can do something similar. Okay, so the average person would look at this and first try and factor it, and I would too. But then you'd realize, okay, I'm stuck. I need to find another way to solve this problem. All right, completing the square will always work. So the thing is, this is not currently a perfect square. This 3 here is messing it up. So whatever our c is, you remember the whole ax squared plus bx plus c. So whatever our c is, we want to get it out the way. So we're going to add 3 to both sides. So we don't have to worry about that 3 for now. It's not making it a perfect square. So that's why we need to get it away from there. So we have on the left x squared minus 6x equals positive 3. All right. So now that we have that out of the way, we can now complete the square. What that means is we're going to try to get this side to be a perfect square. In order to get this side of the equation to be a perfect square, we're going to have to add something on to bulk it up and make it perfect. So what we need to add to this side to make it that perfect square that we want is b over 2 squared. This will always make a perfect square if we add b over 2 squared to to the left side. But as you know, whatever we add to the left side, we have to also add to the right side. So the instruction here is add b over 2 squared to both sides. And this creates a perfect square. So in this case, our b is negative 6. So we have negative 6 over 2 squared, which is really negative 3 squared, which is 9. All right, so we're going to add 9 to both sides. And you'll see how this actually makes a really cool thing happen. All right, so we're adding 9 to both sides, and we get on the left side x squared minus 6x plus 9 is equal to 12. All right. So notice what's happening on the left side. Can we factor it now? And of course, the answer is yes. Two numbers that multiply to get 9 and add to get negative 6 are negative 3 and negative 3. So what we've done, as we were trying to do, is we created a perfect square. So we have, since we have the same thing here as here and here, we can rewrite that as x minus 3 squared is equal to 12. And now we can solve it the exact same way we solved the question on the previous page. So we have to square root both sides, and don't forget, oops, hold on, so don't forget that the square root is positive and negative over here. All right, and so when we square root both sides, we get x minus 3 equals plus or minus the square root of 12. All right, and now we can add 3 to both sides. So we get that x is equal to 3 plus or minus the square root of 12. However, that root 12 is not simplified because it has a factor with a perfect square root. So we should simplify that. All right, so let's simplify it over here. We have root 12 over here, which is the same as root 4 times 3, which gives you 2 root 3. All right, if you have no idea what I'm doing here, perhaps you should consider reviewing my simplifying radicals video. But if you get it, wonderful. All right, so what we have here as our answer then is 3 plus or minus 2 root 3. All right, so I'm about to do a harder one with imaginary numbers and with a number in front of the x and all kinds of good stuff. I advise you to watch it, and if you are lost any step along the way, I'll tell you what you need to learn in order to keep up. All right, great. Okay, so this one is a little bit more challenging even at the start because we have this 2 right here. And when we complete the square, we don't want to have a number, a coefficient, in front of our y squared. So that's easy to take care of, actually. We can just divide everything through by that number. So let's get rid of that and divide everything through by 2. So we're dividing that by 2, and also that by 2. And we get, let me put it over here, y squared plus 2 divided by 2 is just 1y plus 5 over 2 is equal to 0. All right, so now it looks a little bit more like the question that we just did before. So if you recall, this thing here is getting an OR way. We don't want it over there. In order to complete the square successfully, we need to get that over there. So all we have to do is subtract our 5 over 2 from both sides, and we get y squared plus y equals negative 5 over 2. All right, so hopefully you recall that our next step is to try to make a complete square on the left side. So in order to make that complete square, again, the rule is the same. We're going to add b over 2 squared to both sides. Oopsie, that's not how you spell both. All right, so to both sides. And in this case, our b is just 1. There is no number in front of the y, so it's just 1y. So we're adding, in this question, 1 over 2 squared to both sides, which is just 1 over 4. All right, so we have here y squared plus y plus 1 over 4 is equal to negative 5 over 2 plus 1 over 4. All right, so we just added b over 2 squared to both sides. All right, if everything went according to plan, we should have a perfect square on the left side. Let's see if that's true. So we're looking for two numbers that multiply to get a quarter and add to get 1. Two numbers that multiply to get a quarter and add to get 1 are a half and a half. So it looks like we were successful. So y plus a half equals, all right, so when we add, let's actually do it out old school style. We're adding these fractions here. That's a 2. There we go. All right, so we have on the left side negative 10 over 4, and I'm just doing common denominator here so we can add those fractions. So plus 1 over 4. Okay, so since these two things are the same, this is actually a perfect square, as you already know. So we can write that as y plus a half squared equals, and now we have negative 10 plus 1, which is 9 over 4. Okay, so we have not 9, but negative 9 over 4. Okay, so at this point, we need to take the square root of both sides, and some of you are probably saying, oh no, but I can't do that. I can't do that because we can't take the square root of a negative number. All right, so at this point, if you've learned about imaginary numbers, feel free to follow along. If you have not learned about imaginary numbers, this is the point where you'd say there are no real solutions because there is no real square root of a negative number. Again, if you've learned about imaginary numbers, stay with me here. All right, so at this point, since we're taking the square root of a negative number, we should know, if we've learned about our imaginary numbers, so I'm going to keep going here, that y plus a half is equal to 3 over 2i. All right, if you don't know what that means because you haven't learned it yet, don't worry about it. But that's not just 3 over 2i, but plus or minus 3 over 2i. Okay, and so we can take a half from both sides. So we're isolating our y, and we get that y is equal to negative a half plus or minus 3 over 2i. And we're done.